The first one's going to be about solving linear equations and also solving linear inequalities. So we're going to go through first what a linear equation is and what it looks like and how to solve it. Then we're going to talk about different possibilities or types of linear equations, and then we'll jump into solving linear inequalities. Okay. So what we mean by the word linear is kind of like a line. It was y equals mx plus b. Your variable has a first power to it. So we're trying to solve something like ax plus b equals 0. The variable is x, a and b are just numbers. And so you're looking for an x value that satisfies this equation. So when I'm solving this, what I want to do is I want to get x by itself. What does x need to equal? So that's our whole goal. Just isolate the x variable. So let's do a ton of examples. Let's start by solving this equation. We've got x's on all sides of the board. I want to get x by itself. Okay. So before I can start moving stuff to each side, the first thing that's going to make the most sense is to get rid of these parentheses. So let's go ahead and distribute the 5 and then also distribute this -7. And then I can collect my like terms. So on the left-hand side, that will give us 5x minus 5 plus 20. And on the right, that gives us -7x minus 7. So I've still got x's all across the board, but I can condense some things. Like over here, we've got -5 plus 20. So we can make that 5x plus 15. And then on the right-hand side, we have x minus 7x. We can combine those as well, and that gives us -6x minus 7. So I've simplified this to a much simpler looking expression, but I still have x's on both sides. Really, you're going to have a ton of ways that you can solve these things. So not necessarily what I'm doing is going to be your natural first instinct, and that's okay. Go with your gut, because your gut might tell you, okay, well, I've got this 5x over here. Let me just bring it to the other side. So I'm going to subtract it over. My brain, though, I don't like this -x here. So I'm going to go ahead and group the x's on this side. So I'm going to add the 6x over to make these two cancel out. So on the left, that will give us 11x plus 15. And on the right, we have -7 still. And now we're super, super, super close to getting x's by itself. So I've got only a single x expression, but it does have this plus 15. So to get rid of it, the opposite operation is subtract it. So once we subtract it, that leaves us with 11x, and then -7 minus 15 is -22. And now we're so close, we have 11 times x, so we're going to divide by 11. And in turn, that makes those two cancel each other out. So we're left with just x over here, and then -2 on the right. And so we immediately get what x must equal to make this a true statement. Now I know for these kinds of equations, you're not going to go back and you're going to check your answers. I would urge you to on a test just because it's going to help you out. But for these ones, it's not as important. In later sections, we have to check our answers. Let's try another one. This one, unfortunately, is not pretty because it has a ton of fractions. And so again, you can do something that works in your brain. If you're comfortable with working fractions, great. I personally hate dealing with fractions, so I want to get rid of all of these. And so the easiest thing I can do is I can go ahead and multiply both sides of the equation by something that's going to wipe my denominators. So you could multiply by 24, because then when I take 24 over 3, 24 over 4, and 24 over 2, those all cancel each other out. But the simplest number we can actually do is that least common denominator. So remember, this means we're looking for the least number that's divisible by 3, 4, and 2. And so here the number 12 is divisible by 3, 4, and 2. So I'm going to take each of these and I'm going to multiply by 12. Because remember, if I do this on both sides of the equation, it's not going to change anything at all. So my first piece, I'm going to have 12 times 2x plus 1 over 3. Then I'm going to have 12 times x minus 1 over 4. And then here we have 12 times 13 over 2. On this first one now, when I take 12 over 3, it's going to leave us with 4. So we're going to get 4 times that numerator. For the second one, 12 over 4 gives us 3. So we're left with 3 times the numerator. And last but not least, 12 over 2 gives us 6. So we're left with 6 times the numerator. So avoid multiplying things out until you've cleaned up these fractions. Because now from here, we're doing exactly what we did in the last problem. We need to get rid of parentheses, so we go ahead and distribute, and then we get x on its own. So distributing the 4 gives us 8x plus 4. Distributing the 3 gives us 3x minus 3. And then if we take 6 times 13, that will give us 78. So tiny bit of condensing. 8x plus 3x is going to give us 11x. And then 4 minus 3 gives us a positive 1, equaling 78. So super close. To get x on its own, I need to get rid of this plus 1. So we go ahead and subtract it. That leaves us with 11x equaling 77. And then it's really 11 times x, so we go ahead and divide both sides by 11 to get a single answer of x equals 7. So this is the one time when you're solving equations that wiping fractions is super beneficial. In later sections, we're going to deal with different types of inequalities. We're not going to be able to do the same thing. But absolutely, when you have equations, wipe your fractions. So another kind of like subtopic within here, we're going to be talking about zeros of functions a lot. And really, this is another phrase for just saying we're finding the x-intercept. So a zero of a function is just a number so that when you plug it into the function, your output is 0. So it's where you're going to touch the x-axis. So it's a very, very, very specific linear equation that we're solving. So for this one, let's find the 0 of the function that's given to us that has all of these decimals. But all this means is you want to solve where this expression given to us equals 0. Right? So you solve it in the same way. Get rid of your parentheses by distributing those constants. This gives us 1.5x. We distribute the 2, it's 2x minus 8. And if we distribute the 4.5, it's 4.5x. If you do 4.5 times 9, it will give you 40.5. And that needs to equal 0. So I've got lots of terms that I can group together. 1.5x plus 2x plus 4.5x. If we add them all together, it gives us 8x. And then we have minus 8 plus 40.5. Adding those together gives us 32.5. And that still equals 0. Okay. So we still need to get the x terms on its own, so I've got to move this 32.5 to the other side. And that leaves us with just 8x on the left, negative 32.5 on the right. And then finally, we can divide both sides by 8. Those cancel. And that leaves us with x is negative 32.5 over 8, which is a nice decimal. It's negative 4.0625. So if we plug this number in for x into our function, the output will be 0. So another way we can actually think about these linear equations is by figuring out where the two lines intersect. So we've been solving something like this. 3x minus 1 equals negative 2x plus 9. This one is a very simplified version. But this left-hand side is a line. The slope is 3. The y-intercept is negative 1. Here, slope is negative 2. Y-intercept is 9. You could definitely graph both of these things, and then you want these two lines to be equal, so you're really looking for where they intersect. So if I'm considering two lines, I really have three possibilities as what could happen where those lines intersect. So our very first possibility is what we've seen. If I go ahead and graph one line, and then I graph the other line, they could intersect at a single point. So here, there is one solution to that equation. That is what we've seen. A single x value that gives you the same y value. So this is called a conditional equation. Okay. Second possibility, if we've got two lines, is if here's our first line, the other line actually runs parallel to it. So these lines are never going to intersect each other, so there's no solution here. Okay. Because of that, you have no solution. This is called a contradiction. Because the two equations will never equal, it contradicts itself. The last example is the hardest to probably draw. If here is one line, my other line I'm actually going to do in a highlighter, the other line happens to lie right on top of it. So in this case, these two lines are intersecting always. So there's actually infinite solutions here. So this is always going to give you something that is a true statement. So this is called an identity. Okay. So we've done a ton with this first example, but we haven't seen these. The first example is where you get x equals a number. That's every single problem we've done so far. So let's try two more where we're going to try to solve this, and we're going to classify the equation as a contradiction, identity, or a conditional equation. You still solve these in exactly the same manner, just something different happens. So for this first one, I'm going to go ahead and distribute that minus sign still. So this gives us 5 minus 4x is equal to 5x minus 1 minus 9x. And then we can group some things. We have 5x minus 9x. So we get 5 minus 4x equals negative 1 minus 4x. And at this point, you actually could stop if you recognize you have the same x values on both sides, but you have different y values. So this actually is going to be the case of a contradiction. But if you didn't recognize that, that's okay. You still go about this solving the same way. I'm going to go ahead and I'm going to get x by itself. So I'm going to add 4x to both sides. But in doing so, these cancel and these cancel, and it leaves you with 5 on the left, negative 1 on the right. And now I can see, okay, this is something that's completely impossible. There is no solution to this equation. So because there is no solution, this is called a contradiction. Okay. The other thing that you might see is that if there's no solution, we say it's an empty set. There's nothing that solves it. So that's another way to just represent that. For our next one, we're still going to do the same thing. I have a little bit less work to do because I just need to group these two things. So we get 2x plus 1 on the left-hand side, and then 2x plus 1 on the right. And again, I can stop right here. I've got 2x plus 1 equals 2x plus 1. It's the same exact thing on both sides. So no matter what I plug in for x, I'm going to get a true statement. But again, if I didn't recognize that, I'm going to go ahead and move this 2x to the other side to try to isolate x's. And in doing so, both of them cancel. And instead of boiling down to a false statement, I get something that is always true. So in this case, I have an infinite number of solutions. So really, all real numbers is our solution. Okay. So this is an identity. Because really, back at this starting point, no matter the value you plugged in for x, you would get something that is a true statement, which is why it's all real numbers. All right, so when we talk about now solving inequalities, it's a little bit different, but honestly, it's the same process as solving linear equations. Instead of just having a single x value or no x value or all of them, you're really going to get an interval that's going to satisfy the inequality. There are two main rules, though, that we need to keep in the back of our mind. When we're dealing with an inequality, if you multiply or divide both sides by a negative number, you have to flip the sign. So I want to give you just kind of a quick example why. If you have -1 and you have 5, we know the inequality direction goes this way. But now, if I take both sides and I go ahead and multiply by -2, on the left-hand side, I would have -2. On the right-hand side, I have -10. Oh, sorry, +2 and -10. My inequality sign has to flip. So even when I have the variable in there, you've got to make sure that you multiply or change that sign when you multiply or divide by a negative number. Okay? For the same kind of reasoning, it's not going to be a common mistake that happens in this section, but it absolutely will be in future ones. I know we want to wipe fractions a lot of times, but if you have variables in the denominator, you do not want to wipe fractions. So I don't want to multiply an inequality by a variable because of this exact same reasoning. I don't know what happens to the inequality sign. So I'm going to give you just a simple example, like 1 over x being greater than 0. Or let's even make it greater than 4. Okay? A really natural thing in this case would be, I want to take this side and multiply by x, so I'm going to do the same thing over here. My x's now cancel each other out, and I get 1 is greater than 4x. You can't do this because you cannot tell me if x is positive or if it's negative. So I have no idea which rule that I'm in. So this is why we never, ever, 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 ever want to multiply or divide an inequality by a variable. It's just too much to keep track of. Okay? So like I said, it's not going to be a natural thing right now, but I really want to reiterate this. But let's just try some examples with inequalities, and then we want to write the solution to that inequality in interval notation. So you want to do exactly the same thing. You want to get x by itself. So for this first one, we have 3x plus 7 is greater than or equal to -8. I want to isolate my x value. So to do that, I need to move the 7 to the other side. And that leaves us with 3x is greater than or equal to -15. And then I want to divide by 3. It's a positive number, so I don't need to worry about flipping anything. That leaves us with x. And on the left or right hand side, we have -5. Okay. So this is our interval, but we do need to write it in interval notation. So this is why I like graphing those number lines. So -5 is our important point. We can equal it. And then I can take all x values that are bigger than it. So that is everything here to the right. So our solution to this inequality is the first number we can equal is -5, and then we continue to the right forever. So any number from this interval is going to satisfy this inequality. So meaning if I plug in 0, which is in this interval, it's going to give us a true statement. Okay. Let's try our next one. We do exactly the same thing. I go ahead and distribute this -3. So that gives us 4 minus 6 minus 3x is less than 5. Tiny bit of condensing on the left because we have 4 minus 6. So that's -2 minus 3x is less than 5. Let's go ahead and add the 2 to the other side. And so we get -3x is less than 7. And now I need to get rid of that -3. So again, I divide by it, but I'm dividing by a negative number. So I need to flip the sign. So that leaves us with x is greater than -7/3. Okay. So we got to put this in interval notation. So again, going to draw my number line first. -7/3 is our cutoff point. I cannot equal it though because I don't have a bar under here. I just have that strict inequality. And what I came up with is that I could take all x values that are bigger than this. So our solution in interval notation is -7/3 to infinity. Okay. If you want to check yourself with these, it's a little bit harder to do, but one thing you could try is if you pick something in this interval and plug it back in, you could see that it gives you a true statement. So like if I plug in 0, which is a number over here, it would satisfy the inequality. And if I pick something on the other side, I should end up with something that's not a true statement. So it's not a super duper easy way to check, but it works. Let's just do one more of these. And now I've really got compound inequality because I got 2 inequality signs, but same process. I need to get this x by itself, and right now I've got that 2. So I need to subtract it, but what I do to one side, I got to do to all of them. So that leaves us with 0, 3x in the middle, and 6 on the right. Now I need to get rid of the 3, so I'm going to divide everything by 3. And just like in the last example, if this was -3 I was dividing by, both of these signs would change. So 0 divided by 3 is still 0. Just left with x in the middle, and then 2 on the right. So I really have 2 important numbers, 0 and 2. We can equal 0, so I can fill that in. Cannot equal 2. And we can take all x values in between. So our solution in interval notation will be 0 to 2. Bracket around 0, parenthesis around 2.